Have you ever wondered how we know if some of our equipment's going to work? Well, we do it with a lot of testing, and today I'm going to show you some of the equipment that we've built to test downhole instruments that work far beneath the Earth's surface. Let's check it out. So one of the big jobs that we have going right now is measuring microseisms, tilt, and some other parameters downhole inside a well. And we need to be able to go relatively deep in this well. And to do that, our instruments have to survive extreme temperatures and extreme pressures. Electronics and mechanical devices generally don't like either of those. So we're gonna have to do a lot of testing to make sure it works once we get on site. So for that, we've built some new test equipment that really is just about as complicated as the instrument itself in some ways. So I'm going to show you what some of that equipment looks like that we're using to test these new instruments. So this big tube right here is currently still under development. It's letting us pressurize down to several kilometers depth the entire 12-foot length of this tube and simulate underground pressures on our instruments inside. Now this is a very large tube, so I don't know if you get a really sense of scale, but there's my hand. So this end cap will have close to 200,000 pounds of force pushing out on it when this is fully pressurized. So there's about an inch of steel here with lots of weld. And then down here on the other end, we've got this big flange welded on, and we had an inch thick cap on this, but during a recent test, we actually managed to bow that cap out bad enough that the seal failed. So we have some pretty interesting footage from that. So this is a new instrument that we're still working on testing. Once we get the sealing figured out, we're going to build a cart and put it on it so we can more easily roll it in and out, because we do want to test this outside. That way, in case there is a failure of a weld or a seal, it doesn't make a huge mess in the shop. Okay, so that's one way we can test really big things under pressure, but it's going to take a lot of work. There's a lot of force involved, and it's not that easy to set up and tear down. We're using an air-actuated hydraulic pump to set it up. We've got to get all that out and hooked up and working to use it. So we've built a smaller pressure vessel as well that lets us test small things like wire feed throughs. Let's take a look at that. So this is our small high pressure test setup. We've got a manual intensifier that lets us go to 5,000 pounds per square inch. And then this big chunky pressure vessel here. So right now we've got a wire feed through in there. So on the other side of this, there is the wire that would go uphole in the instrument. And we're going to pressurize that to well pressures and make sure that no water gets into the instrument. Now, it's not as simple as making sure that it doesn't leak past the main wire. The water can actually get into the strands of the wire and travel through. So we've done a special process called window stripping inside the epoxy, and we're going to test that out. We've also had some other epoxy tests, trying different epoxies, where the epoxy actually just extruded itself out of the feed through. So we've done some roughening techniques and worked with an epoxy manufacturer to get something that we think is going to work really well here. So this certainly isn't the final video on how we're going to test things, because, well, we're still developing the tools, as you can see. So we've got a lot more work to do on them, but those are the primary two tools that we're going to use for pressure tests. But as you can see, I'm walking through one of our storage areas right now, so it's pretty dark, but I'm going to take you back here to building 4, where we have a tool that you may have seen if you've been following the channel. This is a tool that we call the BEAST, the Borehole Environment and Angle Simulation tool. It's the only one that we have named. As you can see, it's the most highly developed tool. We've had time to paint it and really kind of get it tuned up. But this doesn't let us do pressure testing. It does let us do testing of things like anchoring deployments at various angles. So down here on the base, we have a winch system that goes up to an arm and a pulley at the top, and that lets us make this any angle that we wish. And over here on the wall, we have a temperature controller box that we made that controls a 5,000 watt heater in the bottom of the pipe down here. And so what this tool lets us do is simulate those different angles, make sure anchors deploy right, make sure that things deploy right at elevated temperatures at different angles. The only test that we can't do is a high angle under pressure at temperature test. It's just something that for this job isn't necessary, and it would be very, very costly to develop. So we haven't got there yet. But with these 3 tools, we're able to verify that all of these instruments are going to work as they should when we get them out into the field. And this is all things that we do. We're not selling any of these instruments, obviously, but it's all the things that we do to make sure that the instruments that we do sell you work perfectly and work the first time, every time. So if you want to see more about all the tools that we develop and all of the interesting things that happen here at our shop, or just watch me walk through the dark buildings after hours, make sure that you like and subscribe down below and check out our website, LeemanGeophysical.com.